Welcome to Alchem, helping you understand chemistry one step at a time. In this video, we'll be covering how to draw and name the amine in particular. But let's start with those three substances that has a similar name. So one's ammonia, amines, and amides. So ammonia is one of the simplest nitrogen-containing compounds. It doesn't belong to an organic because there is no carbon in there. So nitrogen, you usually have three bonds. So it could be a triple or double single or three single bonds, and normally accompanied by a lone pair of electrons on the nitrogen atom. And you can draw them in a three-dimensional using wedges and sticks, and it shows a trigonal pyramidal shape. But if you're not familiar with the shape, don't worry about it. And one of the things that students get confused is the difference between ammonia and ammonium ion. So ammonium is an ion with a positive overall charge, and it's got one extra hydrogen to it. So it's got one extra thing. So how I think of it is ammonium has more alphabet compared to ammonia. So it just has one more hydrogen. That's how I think of it. And if this strategy sticks with you, my job's done. So moving on to amine and amide, it's now starting to see carbon atoms. The only difference, okay, I'm showing three covalent bonds, and you don't need to draw the lone pairs, but I'm just drawing it in so you know there's only three bonds there with a pair of electrons. And how to differentiate amine from amide is very simple. Amide would have C double bond O onto the carbon that's bonded to the nitrogen. So how I think of this is having carbonyl group, which is C double O, that oxygen reminds me that little circly bit on the D alphabet, but amine doesn't have any circly parts in their alphabet either. So if you see a circular bit, that means it's got oxygen, so it must be an amide. And there will be another functional group that contains nitrogen, which is a nitrile group, but none of the syllabus will cover nitrile, so we'll actually remove that. And from the next slide, I'll be only focusing on amines and probably go into primary and secondary, tertiary classification as well. So speaking of general information about amines, we got general formula, but in my previous video, I provided the general formula. But from now on, I'm going to teach you how to do the general formula yourself. So having this simplest amine with one carbon and one nitrogen, so I'm just going to draw sticks to represent hydrogens. And once you make this, just create a little table on a little scrap paper to show how many carbons and hydrogen and nitrogens are present as you have longer chain. So in this one, we got one carbon, 5 hydrogens, and 1 nitrogen. And see carefully, I'm just going to add one more hydrogen at a time and try to add hydrogens to it. And if you count them all, there will be 7 hydrogens and still 1 nitrogen. And keep going. One more carbon, so we got 3 carbons, and now we have 9 hydrogens all together with 1 nitrogen. And if you already figure out the pattern of hydrogen, just pause for a minute because I'm just going to do one more to make sure there's a clear pattern. So when you look at this, as you increase the number of carbons consecutively, which means one at a time, check out how the number of hydrogen is increasing. It's going up by 2, so it must be 2 times. So hydrogen goes 2 times, but 1 times 2 is 2, but to make it into 5, you need to add another 3. So once you figure that out, check with 2 carbons. So 2N means you got 4 hydrogen, but adding 3 will make 7. So it'll work for the rest of it. So there's no need to memorize the general formula. You could just create a table yourself and use the sequence skill to figure out the general formula or pattern. And nitrogen doesn't change, so you just got to stick 1 nitrogen as our general formula. Right, and one critical thing that you have to remember is amines are all weak bases, right? So they all have pH greater than 7, and if you take high level IB or A2 in Cambridge, you might be aware that it's acting as a Bronsted-Lowry base by accepting the proton, and it could also act as a Lewis base by donating the electron pair. We are ready to start. So I've got 5 carbons and I'm about to introduce the amine group NH2 at the end of the chain. Then having 5 carbons, would you be able to figure out how many hydrogens that we'll be dealing with using the general formula? So we got C5, H should be 2n plus 2, so that's 5 times 2 plus 3, that gives you 13. So I've got 13 hydrogens to have it all together. I've already got 3, so let's see if it adds up to 13. So there's your 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, ta-da! So it actually does prove it. So here, identifying the amine group and having 5 carbons in the main chain. Some people call this a straight chain, some people call this a backbone, but I'll be using the backbone to make it easy. And it's important to name the prefix. The 5 carbon brings the pent and amine brings the suffix for the functional group. But we don't finish here because we need to show the location of amine group and starting to number the backbone from the side that's closer to the amine. So the carbon on the far right should be the number 1 carbon, and this is your 5 consecutive carbons here. So the actual IUPAC naming is pentane 1 amine. So you can figure out 1 shows a location, amine shows the functional group, pent was for 5 carbons. And before this change in the IUPAC naming system, some people still might call this 1-pentanamine to show the location in a different way, but stick with pentane 1 amine because this is the latest update, latest agreed name of naming this. And let's try condensed formula, reading from left to right without drawing the sticks. So we're starting with CH3 from far left, followed by CH2, 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 and finishing with NH2. But you might have recognized the point of condensed formula is to make things much more simpler, right? And we have a repetition of CH2 groups consecutively 4 times in the middle of the chain. So using brackets CH3, CH2, brackets 4, that'll condense it even further. So let's try to have amine somewhere else. So the structure that you're seeing is still pentane 1 amine because that's just a structure drawn back to front. But now if you move it to the second carbon, this is obviously going to be called pentane 2 amine, showing the amine group is coming off from the second carbon. If I go one more, which is the middle of the chain, you guessed it, it's going to be called pentane 3 amine. So condensed formula, it's going to be a little hard because I haven't done the hydrogens here for you. So why don't you pause the video and try to draw it yourself and come up with a condensed formula and check whether you're right. Okay, now answers are up. You can check them. But if you want to challenge yourself, I'll show you a different way of doing this. Starting with brackets, CH3, CH2, there are 2 lots of it, CHNH2. Pause and really think about how this could be also correct. So if you can do this, you can see the symmetry within the molecule, and that'll be just fantastic. If you can't figure it out, leave me a comment at the bottom and I'll try to show you visually again. let's upskill this. Instead of having 5 carbons in the main chain, this structure will have 4 in the main chain with an amine group at the end of the chain, but it doesn't have to be at the end, but we'll be looking at the variation in the next 10 slides. So having the 5th carbon as a side chain, and it'll also have 13 hydrogens altogether because general formula does not change. And identifying the amine group and having 4 carbons in the main chain, counting from the side that's closer to the amine, so that makes it butane 1-amine for the main chain. And now we're going to deal with the side chain where 1 carbon is coming off, so that's methyl. Methyl means 1 carbon branch coming off the 3rd carbon, so the naming will be 3-methyl butane 1-amine. It's a bit mouthful, and you can have a space between 3-methyl and butane 1-amine, but typically we shouldn't really have a space, but it doesn't really matter in your case. So condensed formula reading from left to right. So we got CH3, which is the C4 carbon, then moving on to C3, which is CH, then CH3 in the yellow highlighted one is a branch, so you must use brackets for it and carry on with CH2, CH2, NH2. But there will be a simpler way of doing this. Now I've highlighted 2 of this 1 carbon, so if you start looking from this point of view, you're going to see 2 of CH3s from that angle. So we can also start by showing CH3 brackets 2, then that leads to C3 carbon, which is CH, then CH2, CH2, NH2, but I've condensed it down further by putting the consecutive CH2 in brackets to show it's repeating twice. And skeletal formula, which is the stick model that shows the structure without showing any hydrogens. To avoid any mistake, I normally do a really tiny dot with pencil to represent there are 4 carbons. Then all you gotta do is just join the dots, make sure the dots are all hidden behind the line, and the current structure actually shows the butane. But after this, you gotta actually put N or even NH2, but do a kind of a half lengthy stick to represent it's actually bonded to nitrogen, not carbon. So if you do a full length, that means that's going to be a carbon. And let's take care of the side chain, the methyl group coming off the 3rd carbon here. And feel free to do NH2, or you can just leave it as NH2. Now your turn. I want you to draw 2-methyl butane 1-amine. Pause the video and try to draw yourself, and I'll be quiet and the answer will be up on the screen by the time that you finish. Nothing beats practice. Okay, let's try one more. So we got 5 carbons all together, but I'm putting methyl group and amine group, amino group slightly differently so you can identify how you're going to name this. So adding hydrogen is always a good practice. All right, and I'm computing for a little space between NH2 group and hydrogen. That hydrogen looks a little crooked, but that's how it's going to turn out to be when you're drawn on a paper. So having 4 carbons in the main chain, remember, we need to prioritize the amine group and start counting from the side that's closer to the amine, right? So this is your number 1 on the left, 2, 3, 4. So the main chain becomes butane 2-amine. And now you can just see it in your brain. The methyl group is coming off from 3rd carbon. So it's called 3-methyl butane 2-amine. So condensed formula, why don't you try this yourself again and have a look at the next structure. So here we have 3 carbon in the backbone, the main chain, and we got 2 side chains here. So I've got amine, and let's fill up the gaps with hydrogen, so making sure that carbon has 4 covalent bonds all together. This one, we've got 2 of the methyl group. So it's 2, 2 because each methyl group is on the 2nd carbon. So it's really important to write 2, number 2, twice to show the location of both methyl group. Because, you know, in a long chain, it could be 2, 3 dimethyl, 2, 4 dimethyl. So it's really, really important. And di represent 2 of the methyl group on the propane 1-amine group. So try your condensed formula But on the second one, which is an advanced version, so we got CH3 here, here, here. So we are pretty much reading back to front. So we are reading from right to left. To start with the bracket CH3. If you can't make sense of this, leave me a comment or email me or let me know so I can show you how it's done. So skeletal formula is pretty much the same. We got 3 carbons in the main chain. So that's your propane so far. And you know what to do with the amine group. So there's NH2 and CH3 as a side chain. Again, for the amine group, you can leave it as N because we can figure out there will be 2 hydrogens coming off, knowing that nitrogen will have 3 bonds, or you can physically write 2 H's in there if you want to. The reason I'm making the video is to try to avoid any careless mistakes that I've seen so many times over many, many years of marking both national and international exams. So this is one of the common one where amines could be classified as a primary, secondary, or tertiary, just like the alcohols and halogenalkanes. But here we are. I've given you 2 structures. One's an alcohol and one's an amine structure. So if you are learning about how to name amines or how to recognize amines, you should have done alcohols already. If you haven't, I actually have got another video on IUPAC name of alcohols, so make sure you see that and see how primary, secondary, tertiary works. And you would know this is a very, very common mistake. So here on the left, it is actually showing a secondary alcohol, but the one on the right is an amine. It looks exactly the same, apart from OH has been replaced by the NH2 group. But this is not a secondary amine. This is actually a primary. Here's a reason why. For the alcohols, we are looking at carbon that's attached to the OH group, which is this carbon, that is bonded to 2 other carbons. So we are looking at how many other carbons that the carbon with OH group is bonded to. Is it confusing? So it's 2 carbons attached to it, and that makes it secondary. But in the amine, we're not looking at the carbon that's attached to the NH group. We are actually looking at the nitrogen atom itself. So we want to see how many carbon that is attached to the nitrogen. So this nitrogen is only attached to 1 carbon here. So we don't worry about the neighboring carbons at all. So this is how you're going to explain the primary nature. Nitrogen atom is directly bonded to only 1 other carbon atom. Capture it. Feel free to use this phrase because that will get you the full mark without being compromised. Since we know the primary, secondary, and tertiary of amines, I'm going to introduce the secondary amines and see how you can name this. So we got 3 carbons on the left, 1 carbon on the right. So now you've recognized nitrogen. The amine group is no longer at the end of the chain. It is embedded in the middle of the chain. So to determine the longest chain, let's actually add hydrogen. So C4, how many H's are we expecting? So while you do the math, I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There you are. So nitrogen only has 3 bonds, right? So I've deliberately added the lone pairs to make sure you don't put hydrogen by accident because it looks like a gap that you want to fill in, but please don't. So having 3 carbons on the left makes it longer chain as opposed to only 1 carbon on the right. So having 3, the prefix will be prop, and it's an N-amine, not just an amine. It's a propan, amine, propanamine at one go. And the carbon that's shown on the yellow highlight will be considered as a methyl group, which is a side chain. It's funny that methyl group is not coming off from the main carbon chain, but it's coming off from the nitrogen atom. So see how it's done? So it's a methyl obviously for 1, and instead of having a number, it's coming off from nitrogen. So it's N-methyl propanamine. And this makes it secondary amine. And condensed formula is pretty much the same. CH3, CH2, CH2, NH, CH3. You don't have to put NH in brackets because this is not a side chain. It's kind of in the straight chain, I might have to say. So skeletal formula goes 1, 2, 3. Then instead of your fourth carbon as a dot, there's a nitrogen here, and the methyl side group will have another dot here. So all you gotta do is join, and make sure you use the kind of a partial stick, which is half and half, and that's about it. And let's move on to the second structure. So instead of having 3 on the left, I'm going to divide this evenly, 2 on the left, 2 on the right, so it doesn't really matter which one you take as a side chain. So having hydrogens again, 11 will do. So you can take this as your longest chain, or alternatively, this as your longest chain because there's a symmetry within the molecule. So having 2 carbon that's highlighted in the gray, I'm going to take that as a backbone, and that's an ethanamine. But now we have the ethyl side chain. So we got 2 carbons coming off as a side chain. So it's not a methyl, it's an ethyl. Coming off the nitrogen, so it's an N-ethyl ethanamine. No numbering is required because there's no branches from the carbon chain. So condensed formula, you can try this, but pay attention to the one that's written right now. Because there's a symmetry again, we can see the CH3, CH2 from the left and right side of the molecule. So we can combine this in brackets and finish off with an NH. Oh, I beg your pardon, I'm missing the hydrogen on the nitrogen atom. So sorry about that. I wish I can just draw it in. Let me just draw this in here. There you are. So it's really easy to make mistakes as I just did, but with practice, as long as you recognize it, that'll be fine. So let's move on to the skeletal formula. So we got 1, 2 carbons on the left, 1, 2 carbon on the right, and nitrogen in the middle of the molecule. Time to move on to tertiary amines. So now we are focusing on nitrogen directly bonded to 3 other carbons. So I'm back to 5 carbons now. So we got 3 on the left, and each carbon is coming from the nitrogen. And we've got 3 and 3, 6, 7, 8, 9, 10, 11, 12, 13. Similar, exactly the same general formula. So just showing a lone pair again. There's no hydrogen on the nitrogen because nitrogen already has 3 bonds there. So the highlighted gray box shows the main chain. Now you should know the prefix for 3 carbon is prop. So it's a propanamine, propanamine. What should we do with the side chain? So we got one methyl group, another methyl group. So we're thinking dimethyl, and both are coming off the nitrogen atom. So you need to do N, N. Remember that we need to show the location of the side chain. They're both coming off from the nitrogen. So make sure you do 2 capital N's to show this. And condensed formula, CH3, CH2, CH2, N without the hydrogen, and we can combine the methyl group using brackets. Skeletal formula, you got it. So try this yourself and see if it matches. So we got 3 dots for 2 represent 3 carbons, nitrogen, and there will be another carbon. There will be another carbon. Just have a look at the positioning of this. So we got that, nitrogen. Now this is the first side chain, and this is the second side chain. I mean, it doesn't have to be drawn in a nice, perfect triangular shape because the bond angle happens to be 107, but that just looks more stable, I guess. That's why organic chemists do it this way. Trying the second tertiary amine structure. So we've got 5 carbons altogether, but they now are split into 2, 2, and 1 carbons. And I won't actually do the hydrogen because we know there are right number of hydrogens anyway. So you can take this as a backbone or take that as a backbone. So I'll be taking the carbon that's in the gray box as a backbone. Having 2 carbons, it's going to be an ethanamine, ethanamine. And now we are viewing this as your side chain, which is an N-ethyl coming off from the nitrogen, 2 carbon side chain. And the other one, we already know this is the methyl group coming off from the nitrogen. So this is what you need to consider when you have two different branches. We can't really combine them because one's an ethyl, one's a methyl group. Then we go by the alphabetical order and see whether E for the eth or M for the methyl comes first. So E comes first, so we need to address the N-ethyl, N-methyl ethanamine. Yeah, if you can name it, wouldn't you feel really good that you can actually come up with this long gibberish name, which actually do make sense to people who actually knows what they're doing. So condensed formula, CH3CH2, N. Then we are seeing methyl group as a side chain of the side chain. So use the brackets to avoid confusion and coming back to address the ethyl group. Or if you did see symmetry already, you're very, very good. So now we are seeing two of the carbon chains as a symmetry there. So we can put those in brackets and finish off with the NCH3. So skeletal formula, you can try this and check it. Well done for grasping all basic skills to name and draw the primary, secondary, and tertiary amines. But it's time to apply your knowledge. And if you get given this complicated structure showing morphine, not that we need to remember or memorize the structure, but morphine is the best painkiller. But it can actually get turned into heroin, so that's one of the drugs that needs doctor to be administered for the severe pain like cancer. But anyway, if you are given those complicated structures, the frequently asked question will be identifying all functional groups in there. And you can't really possibly name this whole molecule, and that's why it's got a special name called morphine to avoid any confusion. So here we've been doing amine so far. So can you identify where the amine is? And if the question asks you to circle it, do not circle just nitrogen. This is a big no-no where you're going to lose a mark, because depends on primary, secondary, and tertiary nature. You need to show the carbon that's bonded to the nitrogen again. Yep. So here we got nitrogen. I've included 3 carbons that are directly attached to nitrogen. This is how you need to circle it. I've used the highlighter, but you can use your pen to include all 3 carbons if they're tertiary, or include 2 carbons if a secondary. So that gives you amine, or you can call this an amino group because there are other functional groups other than amines. So it's actually more accurate to say there's an amino group to it. Amines are usually used if there's only NH2 group in the entire organic compounds. But if there are other functional groups, we change the name into a prefix and call it an amino group. And since we've got this, let's have a look at other functional groups too. So you might recognize the OH, which is the alcohol. Luckily, we don't have to include the carbon that is bonded to the OH group. So that's an alcohol or the hydroxy or hydroxyl group. And we got 2 of those. Let's see if you have, actually, if you want to know what the classification of this alcohol is, the carbon that's bonded to OH is now bonded to 2 other carbon. That makes it secondary alcohol. Whereas the amine, it was a tertiary amine like so. And the ones that are highlighted in green, if you could recognize that the C to C double bond, alkene or alkenyl group, you've got it. And let's see one more. There you are. This is an ether, which is C, singly bonded to oxygen, singly bonded to carbon. And be mindful, I have included all, both carbons that are on the right and the left hand side of the oxygen. So make sure you circle both carbons, not just the circle around the oxygen. There's a big tip for the exam. More application here. These are some biogenic amines. Bio means living things, so biogenic amines are naturally occurring amines, right? So they can be naturally occurring in your body, naturally occurring in the organisms around us in the nature. We won't be able to name them all, but if you look at the name histamine, can you see what functional group there is? And some of the name will represent the functional group in it. So it obviously contains amine, and same goes with the this third structure, trimethylamine. This could be a very, very stinky molecule. So amines are quite basic, as I said, and it actually has some sort of unpleasant smell like rotten fish or the armpit smell, because you know the sweat and the rotten fish, they actually contain some type of amines. But here I want to actually challenge you to name this structure. So it's got two amine group which we haven't dealt with yet. So we got to use di for di to represent two of the amine group. And let's have a look at how many carbons there are. So each corner represents carbons. So there's 1, 2, 3, 4 carbons in the main chain. And the amine comes from the first and the last carbon, which happens to be C1 and C4. So this will be named a butane for 4 carbons, 1, 4, showing the location of amine group, and check the suffix, it's a diamine for 2 amino groups. So let's move on to the second structure. Oh, actually I'm showing the current IUPAC naming that has a tick next to it, but some people will call 1,4-diaminobutane, treating the amine group as a prefix. But this is a really old way of doing this, so try not to do this anymore and stick with the one that's currently IUPAC. And let's move on to the second one. All right, so second one would look very similar to the first one, except for it has different number of carbons. So why don't you count how many carbons there are while I'm speaking and determine which carbon that amino group is coming off, which is 1 and 5. So that will be pentane 1, 5 diamine. So it should be getting straightforward. And for the next structures, it is quite difficult for you to name it because it's got a secondary structures in the middle of the chain, primary structures at the end of the chain, so you will never get a question to name something like this. But instead, you might get a question to identify, oh, which one's a primary, or how would you classify this compound? So very last structure that we're going to look at, it has 3 amine groups. The one that's highlighted in blue is a primary amine, and guess what? Nitrogen is only bonded to 1 carbon, so we got 2 primary amines. For the second one, if you circle it like that again, you're gonna get a penalty. You'll lose your mark because you are not including the 2 carbons that are bonded to the nitrogen here. If it's a secondary and tertiary, it makes a big difference. So make sure you include 2 carbons on the either side to emphasize that's a secondary amine. So it is possible to have one compound that is primary, secondary, and tertiary all together, or the different combinations of it. This will add to your general knowledge. The vitamins, it's actually a combination of 2 different words. Vita means something essential. So you have heard about vital signs, or if somebody says, oh, this is the vital moment, this means something very important. And the second part of the word is used to describe amines. So in olden days, vitamin was the essential amine that body requires. So without this, you might have to risk your life. So having lack of vitamins, it might lead to many diseases like scurvy if you're lacking vitamin C's, right? So here, I'm going to show you some vitamin structures. So this is vitamin B1. Vitamin B12 is more massive, so this looks like that. But you can see there's a lots of nitrogen containing group, and the one that's highlighted in the yellow highlight means it's an amine group. So in olden days, they thought all essential substances that are essential for the body will have amines in there. But as the scientists discovered more and more, they've discovered vitamin A, vitamin C, and they actually don't have any amine groups in their structure. Instead, they have the hydroxyl group, alkene group, or carboxylic acid or esters. They had all other groups but amine groups. So scientists had to change the name from amine into vitamin by getting rid of the E at the end, so it doesn't give any incorrect perception that it's an amine. So this is one of the cool things to kind of find out where the word came from. So if you have learned something from this video, I'm really, really grateful. So hopefully you can practice, and practice makes it perfect. So keep learning, keep practicing, and thank you very much for watching.